Hello, dear students. This video record is about straight lines. In AutoCAD, how we can draw a straight line, not arbitrarily, of course, technically. I want to answer this question in this video film. For a few years in AutoCAD, in using two-dimensional tools of AutoCAD, not three but two, the facilities of AutoCAD, we have two alternative techniques, or say method. The one, it is still applicable. It was the only method beforehand. I'm going to say not old, but since it is still is used and in future probably going to be used by some users. So I'll say classical method. The other one is the method today in new generation softwares in sketch mode. We use that method. Say parametric drawing. Or say that constraint technique. It is the method, it is used in drawing the figures for having the necessary the sketches in new generation software. We use the new method. I'm going to say method of today, or in short, I'm going to say modern method. Classical method versus modern method. In modern method, we create the entities in general, any entity, whatever it is, straight line or any circle, etc. Arbitrarily, and then upload it is characteristics, geometrical and dimensional characteristic using the constraint tools of software. In this video record, first I'm going to make some demonstrations, give some examples, selecting classical method. Okay, and then after reaching to a certain level of experience, it's going to be the time to focus your attention to a certain projection, depending on the level of difficulty. Say that may be the simplest projection to draw. Study on an example, and then study on that example one more time, in that case selecting the modern method to apply. Okay, let's start. This is AutoCAD, and from the ribbons you can see that the mode is two-dimensional mode. If you drop this list, can see that it is so mechanical option is the selected option. This means the environment is two-dimensional. In the screen, what I have the template simulation. This file which I opened already, my template file. So my template is okay to it is layers. Its structure is ready to start. I dropped the list of the names of the transparent papers, and I have the necessary layers for practicing on piece of straight lines, circles, rectangles, any basic geometrical entities, and thereafter the complete views, the projections of something. So my template is ready. No need to repeat the same things and lose time. See the advantage of using a template. Already configured, already structured my template, and then simply open my template, and I am ready to start. Since I'm going to use AutoCAD for two-dimensional drawing purpose, you see over here at the top right corner I have orientation cube. No need to use orientation cube in two-dimensional environment. So I'm going to take it as visibility from the screen. Remind you how. Select View tab and then toggle off View Cube button. Yes. Take it, that unnecessary tool away. Navigation bar, yes, may be useful for making zoom in, zoom out, but mainly to set all the things in the content of the drawing paper in full size to the screen. Zoom all facility. For instance, zoom out or zoom in, clicked on zoom extends button. Then the content and thing will be in full size in the screen as matched. So keep navigation bar. User coordinate system icon, yes, is on to see coordinate frame in the screen. It's useful to highlight that space is two-dimensional. And at the paper invoking stage, we defined this corner as the origin. So zoom in, zoom out, and check whether coordinate frame is just at the commonly agreed place. Origin is at the corner, bottom left corner of the paper simulation. So x-axis is coinciding with the edge of paper, bottom edge of paper. Y-axis is coinciding with the left-hand side edge of the paper. That is the coordinate system. Okay, to locate, to mark the points in the working area. The region bounded by margin lines, is called working area. Okay, I selected the classical method first. I'm going to demonstrate how a piece of line is created in this method. Well, manually, for being safety side, why not? I may need to use the tools of that menu bar. Clicked on this listing arrow and then select Show Menu Bar option to have, to add, to invoke drop down menu bar between the quick access and tab menu bars. Okay. Well, home ribbon, and this panel is the region to find the drawing facilities. Okay. Well, this is the button, obvious, from the symbol on the tab, is to create piece of straight line. The next one is to create piece of straight lines, but in sequence, polylines. Well, the advantage of using this tool relative to the other one is that, if the boundary lines are straight lines only, okay, of a region, well, if we draw the boundary lines using polyline facility, then in the end, the area bounded by the lines will be ready to indicate for 3D modeling purpose. Well, the area bounded by polylines will automatically be defined or considered by the software as a region. Instead of using polyline facility, if we create the lines while using this tool, well, when we finish the drawing, then expand the drawing paper, drawing panel, with a click, and then while clicking on this button, define the region, define the area bounded by the boundary lines as a region. If, of course, it is necessary to do such a thing, if the area, the surface bounded by the boundary lines will be indicated as a region for creating the solid model of the object or solid model of the feature of the object, depending on the case. So instead of applying the region definition process, and via which using a certain time in the order of 1-2 minutes, well, it is advantageous. Just create the boundary lines using polyline facility. It is recommended. Okay, well, say that the straight line to draw is the image of a flat surface. Why we have straight lines, okay, to draw, say, for having in the end the projection of a certain object. See an example. For instance, here, this is the photograph of the object. Well, there is a flat surface here in the design of the object. There is a flat surface. While observing the object in a certain direction, such a flat surface appears to its edge view. If the surface, which is a flat surface, is perpendicularly oriented with respect to the picture plane, then its projection will be a piece of straight line. Yes, the image of this flat surface corresponds on this view. It is one of the side view of the object. This straight line corresponds to the image of such a flat surface. Well, here in this example, there is a hidden rectangle here with straight lines, horizontal, horizontal, vertical, vertical. Why? Because, well, in the structure of the object, there is a rectangular prismatic extension. Okay, while observing the object in this direction, that rectangular prism relative to the observer will be hidden. Okay, so you know the alphabet of the language. If the entity relative to observer is hidden, then its projection is drafted using dashed lines. This dashed rectangle corresponds to the image of this rectangular prismatic extension. Okay. Why we have straight lines? Because the rectangular prismatic extension has flat surfaces. Since the flat surface of the prism are perpendicular to the picture plane of this view, we see their images in form of straight lines. Another example, for instance, here you see there are 1, 2, 3 flat surfaces. While observing the object in this direction, we see the flat surfaces to their edges. Okay? Well, this straight line is the edge view of that flat surface. This straight line is the edge view of this flat surface. And this piece of horizontal line is the image of this flat horizontal surface. Yes, so, well, you see, for having the images of the objects, well, if in the design of the object there are some flat surfaces, there will be correspondingly straight lines as their projections to deal. So, well, in this example, saying that in this video record, how a piece of straight line can be created. In answering this question, let me say that imagine that you're drawing the projection of an object, and object has a flat surface, and that straight line is the image of that flat surface. Okay, assume that a flat surface is directly observable, visible, so the image of the surface is a visible outline. So to be able to have the image as a visible outline, you know the thing to do, drop the list of the transparent papers and then select one of the visible outline layers. I selected the first visible outline layer. You know how, drop the list and then making a click on the name of that layer. This means as if I opened the notebook and selected such a page. Well, the selected page, the name of the selected page will be in the display, layers display, can be seen over there. It is the indication that visible one is the selected page. And then start the line drawing process. Piece of straight line. Polyline, you know the advantage of this. Polyline or single line, depending on the case. Clicked on the process button and start. And then system asking the location of the starting point. You see, since dynamic input button, which is along the status bar, it is over here, my cursor is indicated that, is on. Whenever we start a process, it is always true. In the vicinity of cursor, we find some rectangles in sequence. It looks like for me, as I said already, a train, like a train. It looks like a train. First compartment from the left is just may say, if you want, locomotive. Within the locomotive you can see the thing to do at this stage. It is prompting. And the other boxes, other compartments, most of the cases are used to input coordinate values and or size values. Okay. Specify first point. Well, I'm going to use case study technique, and in this case say that we know the coordinates of the starting point. Where is the location of the first point? It is the point to start. Okay, assume that the coordinates of the point are given. Seldomly it may be the case actually. For instance here, for this example, none of the points you see starting point, the coordinates of the point, none of them, the coordinates are available relative to absolute origin. So while drawing such a projection, it is said select one of the points to start and then with an arbitrary click mark it on the paper. Indicate that location as the starting point. Most of the cases, yes, we do such a thing. But here in this example, say that the coordinates of the starting point are available. Say that the abscissa value is 100. Okay. And then after writing this number into the second box, click on comma key. And then into the next box, it is to write the ordinate values. Write the ordinate. Say that ordinate is 120. Yes, press enter. And then since dynamic input button is on, well, we see not only train in the vicinity of the cursor, but well, the output of the process together with the helpful associated things. These are simulated. The eggplant color line, no doubt, is the output of this process. But the dotted lines, you see, well, two parallel dotted lines, just like extension lines, okay, to extend the size of the line to its vicinity. And the third line with the box, it is now with a blue background color, corresponds to the length of the line. Well, the other simulated line is a circle arc and a straight horizontal line. These are in dotted form. AutoCAD making such a simulation saying that into the highlighted box write the length of the line, if you know, of course. Okay, into the other box it is now not active, but it is just over the simulated circle arc. Write the inclination angle, degree symbols, notice us that it is so. Well, writing the inclination angle, well, if dynamic input button is on, this is important. See the simulated arc, it is extending in which direction? Relative to the horizontal dotted line. And then write the inclination angle as measured in the direction in which the arc extends from the horizontal reference line toward the line which is the line to be created. Well, here the angle is to be written in the counterclockwise direction, but if the line is just ready to create as downwardly inclined, then see simulated arc is in which direction? It is in clockwise direction. Well, here if there is an arc simulation, don't forget this. Not a matter the line is arc is in clockwise direction or in counterclockwise direction, it is extending. Well, write the inclination angle to its positive value always. If there were no arc simulation, then I would say that write the inclination angle in such a case, say that there is no arc simulation, but the line is downwardly inclined. So since AutoCAD always, if there is no arc simulation, always measures angles relative to horizontal line, reference line, in the counterclockwise direction using positive angles, angle values, positive angle values, well, it is important. Well, toggling the dynamic input button, for instance, make it off, and then say that at this stage you need to write the inclination angle. You know the difficulty. If the dynamic input is off, then cannot find the boxes to write the inclination angle. Well, need to write the angle into the comment bar. But in doing this, be careful. If there is no arc simulation, then, well, see, the line is downwardly inclined or upwardly inclined. Relative to horizontal reference line, imagine that it is passing through the starting point of the line. If the line to create is in the downward direction, inclined in the down direction, then write the angle as negative. But if the line to create is to be upwardly inclined, then write the angle as positive. But it is tricky, you know. But if dynamic input button is on, then, well, always write the angle as positive. But as measured, well, if the arc is in this sense, simulated arc is in this sense, then as measured in the counterclockwise direction, write the number positive. If it is simulated like this, then write the angle again to its absolute value, but as calculated in the clockwise direction, as measured in the clockwise direction. But always write the number, no doubt, as positive if dynamic input facility is on. See the dotted circle arc and then accordingly calculate the inclination angle and write it. Okay, close this parenthesis to notice or to remind you on such tricky important things. And then, well, turn back to our case. Say in this case, in this example, yes, we input the coordinates of the starting points relative to the absolute origin, and then now it is the following stage. At this stage, program just using this simulation, noticing me that at this stage I need to write the length of the line. In this example, say that the length of the line is 80. Into the box write 80. And then, well, there is a trick at this stage to know. If you're going to input this number as the length of the line, and then the other number as the inclination angle, yes, this is a must. Click on Tab key of the keyboard. Which key is Tab key? In the structure of the keyboard of computer, you can find the tab on which there are two arrows. One of them is to the right, the other one directed to the left. It is the Tab key. Click on Tab key. Don't forget this. Well, if clicked on Tab key, then AutoCAD understand that, well, the first number is the length, and you see within the box now we have log symbol. It has been, means it has been recorded as what? As the length of the line. And then, well, within the second box now we have blue background color. This means the box is ready for our typing. Well, degree symbol implies that it is the angle, inclination angle of the line. Well, see the arc simulation. It is in the counterclockwise direction. Okay. Do you know the angle as measured in the same direction? Yes. If yes, then, well, write the number to its absolute value always. Say that in our example, the angle of the line is 35 degrees. No need to write degree because AutoCAD ready to consider that number in degree. Okay. And then the rest. Press enter. That is it. Yes, the created line is the corresponding output. Its length is 80, inclination angle is 35 degrees. Okay. Well, line creation process, it is started clicking on this button is endless process. You see now I created the line, but program still running the subroutine. It is for outputting piece of straight lines. But here pay attention please. It is automatic. AutoCAD didn't ask me on the starting point, first point for the new line, because AutoCAD automatically considers the ending point of the preceding the created line as the starting point for the next. And now you see, well, program ready for the new creation. Well, the new line is to be created in the down direction, extended to the right, for instance. And then, well, right its length. Its length is, say that, 100 millimeters. And then clicked on tab key. Why? Because the number which I wrote it is the length, and the other number is the inclination angle. Here you see the angle simulated circle arc. It is from the dotted horizontal reference. It passes through the starting point toward the line which is ready or about to be created, is in the clockwise direction. Since we have an arc simulation, it is not a matter whether the arc is clockwise in clockwise direction or counterclockwise direction. Write the absolute value of the inclination angle. Say that the angle, inclination angle of this line is 30. And then press enter. And so on and so forth. Yeah, create one more line. Yes, I'm going to create such a line right now. The length of the line is 130, let's say. Yes. Clicked on tab key. Now I see that angle is ready to considered by the system as measured in the clockwise direction relative to the horizontal dotted line. Well, angle, according to right angle, it is now an obtuse angle. Say that it is 160 degrees. Okay, press enter. Okay, and then, well, you see, this is not polyline process, polyline creation, single line creation process, but you see it is possible to create the lines in sequence. Preceding line and then following, preceding, following. But if at the end the region bounded by those lines going to be indicated for applying extrusion process, for instance, well, the region is to be defined as a region. Okay, because the boundary lines are created, will be created using piece of straight line facility. The lines are in sequence, but when we attempt to apply extrusion process, the area bounded by those lines will not be recognized as the as a region. Region definition process is to be applied. You know how? Clicked on this and then clicking on this region definition button, define the region, the area as a region. Okay, say that one more line is to be created. Well, in this example, the line to create at that stage is for closing the boundary, closing the figure. It is the closing line. I don't know the coordinates of the ending point. I don't know the length of the line, but I know what? I know that the last line is to extend from its starting point to the first point of this series boundaries, the starting point of the first created line. Well, how can I create such a line? Well, use snap facility. Yeah, I don't know the length of the line. It is to close the region. Okay, the figure. I don't know its inclination angle, but I know that it should find its ending point just as coincided with the starting point of the first created line. So, well, use snap facility. Toggle on snap enabling button. Enable software to indicate the characteristic points. Okay. to snap the cursor. Drop the list of the characteristic points and then check whether the terminal points have been enabled, say selected and software enabled to snap the cursor when the cursor is close enough to an endpoint. Yes, in my computer it is okay. Endpoints, you see this terminal point is an endpoint. So for endpoints there is an enabling. With a click you can make such an enabling, and then this means when I bring the cursor to the vicinity of such a point, then yes, although cursor is not at infinitesimally small distance but at a finite distance away, at the point which is the point to snap the cursor, can see a green highlighted symbol. It is the indication that cursor is sufficiently close, and with a click can indicate that point as well in the process to say that the last point, second point of the line, which is ready to be created. Okay, with a click indicate that highlighted point as the ending point for this new line. That is it, and it is going to be precisely created to its necessary characteristics. Now you see this is a closed figure, but not defined as a region yet. Okay, define it as a region. You know how. For instance, now bring the cursor onto this line. You see it is highlighted independent from the others. Click. Well, after indicating the line, I see the blue boxes where at the characteristic points, terminal point, and this is the midpoint. Press escape button, indicate the other. You see we have lines are in sequence, but well, these are not dependent to each other yet. Okay, these are independent lines because I created this figure using single line facility. To be able to define the surface bounded by those lines as a region, or to be able to make the boundary lines are as dependent lines to each other, apply region definition process. Expand the drawing panel and then clicked on this button, region. And then using windowing method, well, not one by one, but to be able to select more than few entities simultaneously, we use windowing method, you know. Take the things into window and then finish this selection stage. It is also going to be the last stage of the region definition process. Simply clicking on enter key. That is it. Now it is a region, and then if you bring the cursor at any point onto one of the boundary lines and then click the mouse, you see, well, at the characteristic points of boundary lines we see the gripping points, blue boxes. This is the indication that the lines are just in sequence connected to each other. Well, instead of wasting time clicking on this title and selecting region option and windowing method and pressing enter, just, well, it is recommended if you're going to use the lines for having a region in the end, thereafter to apply extrusion process or revolve process or sweep, whatever it is, in general say that's solid model creation process, then it is preferable select polyline tool and then create the lines using that facility. Well, after starting the process, the things are the same to deal. Well, specify starting point, say that, okay, well, press escape button, and then to be able to make it distinguishable, well, I'm going to create a similar figure, but using polyline facility. Assume that this is the projection to create invisible layer 3. I'm going to change the paper, okay, and then start polyline process. Now system similarly asking me where is the starting point. Say that starting point is the one at the place it is coordinate abscissa value is 250 millimeters. Okay, clicked on comma key and then ordinate value 140. Press enter. Here is the starting point, and you know the rest is the same, actually very similar. The line, the first segment of the boundary is being simulated. Say that its length is 50. Clicked on tab key. Its inclination angle is 30. Press enter. And then, well, move the cursor in this direction for seeing the simulated things convenient for your inputting. Well, the length of the second segment is 80. Clicked on tab key. Well, the inclination angle is 35. Press enter. And then move the cursor in this direction. Okay, say that the length of this segment is 100. Clicked on tab key. Inclination angle 160 degrees. Press enter. Okay. And then one more line. Say that it is over here. And then the closing line. Use snap facility. That is it. Yes. But you see it is automatically going to be defined as a region. No need to apply region definition process. If you create the straight lines using polyline facility, then in the end, after having a closed figure, closed boundary, the area bounded by the lines will be a region. And the lines will be not independent from each other, will be in sequence. In continuation will be the same boundary for the region. Okay. Yes, first case I think is okay. In this case, you know, we know the length of the line, we know the inclination angle. Well, in other case, I'm going to change the layer visible to. In this case, well, instead of knowing the length of the line, which is the line to be created, we know an inclination angle. We know the shortest distance in the horizontal direction between its terminal points and the shortest distance in the vertical direction between its terminal points. In other words, for the line it is needed to be created at this stage is, we know delta x and delta y values. Okay, see how such a line is created. I started the line creation process. You know, if you're going to have in the need to have a region indent, then for saving time, clicked on polyline button. Okay. If you're going to have the figure only, not apply solid model process, then not a matter, you clicked on this or the other. Well, okay. Take the advantage of using polylines. Clicked on this button, and then system asking me on the starting point. If you know the coordinates of the starting point, okay, then write the xy values. Okay. Assume that coordinate values are 40 and 130. Okay, 40. Clicked on comma key, 140 is the ordinate value. Press enter. And yes, simulation has started. The first point is at the place for which I input the xy values. And then, now the line is to be created. Ready. Although in the simulation it is obvious that system is ready to gather the number as the length of the line, but in this example say that I don't know the length of the line. I know delta x value, I don't know inclination angle, I know delta y value. Saying delta x, delta y, I mean, repeat again, the shortest distance between the terminal points in the x and y directions. Say that delta x value is 50. I wrote 50. And now, to be able to teach to the software that this number is not the length of the line but delta x, it is a trick. Do not click on tab key. Click on comma key. Okay? But here it is important. I am saying delta x. to be able to teach to the software that it is delta x value, not x but delta x, well, dynamic input button must be on. If dynamic input button is on, then no need to say add symbol, no need to use add symbol. But if it were off, then to be able to teach to the software that the number written for the second terminal point is with respect to not the absolute origin, but with respect to the first point preceding the located point, and it is not x but delta x value, I would bring at symbol first. But here no need, because while dynamic input button is on, to be able to teach to the software that 50 is not the length but delta x value, not relative to the absolute origin but relative to the first point, starting point is the abscissa value, simply clicked on comma key. Yes, you see AutoCAD understood that it is a different case, so well took the simulation from the screen, arc simulation from the screen. AutoCAD understood that first number which I input is delta x value. And then write delta y value. If you're going to create the line as upwardly inclined, delta y positive. If the line is to be created downwardly inclined, delta y must be written as negative. It is important. Using relative coordinates, don't forget to consider the direction. If the line is to extend to the right, then delta x positive. You see line is ready to extend to the right, delta x positive. If the line is to be created to the left, then write delta x as negative. Since I wrote the number as positive, now you see AutoCAD simulating the line as extended to the right. But say delta y value is not input yet. Shall you create the line upwardly inclined or downwardly? I'm going to create the line upwardly inclined, so write delta y value while the third box along the train is to accept or to write delta y value as a positive number. Say that delta y is 60. Positive. Press enter. That is it. Yes, the line has been created. And then continue. Well, see one more example, one more exercise. Okay, say that now the second line is to be created as extending to the left and in the down direction. Okay, simulation is still the same. AutoCAD just ready to gather the numbers as length and inclination angles. But at this stage, I'm going to teach to the software that it is not the case. Into the highlighted box, write the number, say that it is 60, but it is not the length. If it were the length, I would click on tab key. But to say that it is delta x, okay, write the number. Well, since the line is to be extended to the left, write this number as negative, minus 60. Well, this distance will be measured by the software relative to the starting point in the x direction, negative sense of the x direction. Okay. Clicked on comma key. It is to teach to the software that well, the written number is not length. Obvious that length cannot be negative, but it is delta x. Comma key. Clicked on not tab key but comma key of the keyboard. Okay, and then well, AutoCAD understood and took the arc simulation away from the screen, and then waiting my typing. Say that line is to be created in the down direction, so write delta y value into the third box as negative. Say that its value is minus 10, and then press enter. Yes, here it is. That is the line. I think it is clear enough. Two different cases studied. Creating those lines, well, in the scenario I said that we know length and angle. But creating these lines in the scenario I said that we know delta x, delta y values. I hope these are clear enough. Well, in other case, you may need to deal, you may have, okay, in this case, well, a line is needed, okay, not only one line, but in some cases you need to create few lines. These are either horizontal or vertical, okay. So, to be able to save time in such a case, well, it is recommended click on Ortho Facility. If Ortho Facility, you know, already talked about the advantage of toggling on such a button. Well, AutoCAD, without asking the inclination angle of the lines, okay, automatically can fill in the angle box, just sensing the way of the cursor which you are moving. See, well, assume that we have some lines to create in which layer. Well, in this example, say that the lines to be created are hidden lines because the surfaces are hidden and their images are to be drafted, are to be created, say, using dash lines. So, well, drop the list of the names of the layers and select one of the hidden line layers. And then start the line drawing process. Starting point. Well, here, in other case, assume that I don't know the starting point, the coordinates of the starting point, but I know that the line is to start from this existing point. Well, what can I do? Instead of trying to find or determine the XY values, just indicate it. Snap facility is on, snap button is on, and enabling is okay. For endpoints, there is an enabling. So move the cursor to the vicinity of this endpoint, and then after seeing the highlighted square, green square, can conclude that cursor is sufficiently close and that point can be indicated, or that point can snap the cursor. With a click, indicated. And then move the cursor in the sense. You see I am oscillating the cursor, but since I already clicked on Ortho Facility, Ortho tab, AutoCAD keeping the inclination angle, sensing that I am moving the cursor to the right, as equal to 0. Yes, that number, inclination angle, is automatically produced by the software and written into the box. So I do not need to write the inclination angle. Need to focus my attention only the length of the line. Say that length of this line is 40. Press enter. And then, well, the next line is to be created in the up direction. You see, I move the cursor in the up direction. Program understood that angle is a vertical, upward directed vertical line, so it automatically wrote the inclination angle as 90. Length of this line is, let's say, 35. Clicked on tab key. Well, not necessary to click on tab key because no need to write the angle. Just press enter and then move the cursor to the left. You see AutoCAD understood that while the line is to be created in this sense, when wrote the angle automatically as 180 degrees. Just write the length of the line, it is 50, and press enter. No need to click on tab key and type the angle because angle has already been input by the software itself. Okay, press enter, move the cursor, press enter, move the cursor, write the length, press enter, and so on and so forth. Yes, press escape button and finish the execution. In other case. Well, what I am doing, I'm talking about and demonstrating the things to do for creating piece of straight lines. But in doing this, I am using classical method. In classical method, while we are creating the entities, we write the necessary numbers, coordinate values, length values, okay? It is classical method. And using classical method, we use snap facility, Ortho Facility, etc. toggle of ortho, and then in other case, assume that you have a line, it is to be created. Which one? For instance, invisible outline layers, number 3, a line is to be created as a certain boundary line. But in this example, in this case, I don't know, we don't know the starting point and, the coordinates of starting point, coordinates of ending point. We don't know the length of the line, we don't know the inclination of the line. So we know what? We know that line starts at an already marked available point. For instance, it has available thanks to the existence of the precedingly created projections, or thanks to the existence of the point which has been marked in construction layer, or using transfer lines it has been marked. Whatever the case is, we know where is the starting point, we know where is the ending point. Okay, for instance, starting point is this corner. Where is the ending point? Assume that, already located those, created those transfer lines. You know, previous record, I sufficient talk about transfer line technique to mark the points. Say that a point has already been marked as the necessary point at this stage to deal. Okay, and now, at this stage in the example, in the scenario, it is necessary to create a line. It is to extend from this corner to this intersection point. I don't know the length, I don't know delta x, delta y, I don't know the inclination angle, but I know where is the starting point, where is the ending point. This case may be the simplest case, easiest case to deal. Start the process, line creation process, and then use snap facility. Yes, endpoint can snap cursor, intersection can snap cursor. So here check whether endpoints and intersection points there are enablings. Yes, for both of them enabling. So indicate this highlighted point with a click as the starting point. Indicate this intersection point, it is now being highlighted with a click. That is it. Here is the line. Okay, clear, I think. And in other case, it may be the issue to deal. Say that create a line, it is to extend from an already marked point, okay, and is to end along, for instance, this boundary. But here there is such a difficulty. The ending point of the line, which is the line to be created, is along this boundary. But it is not at a characteristic location. It is not at the terminal point. It is not at the other terminal point. It is not at the midpoint. If starting and ending points are just the characteristic points, those can snap cursor thanks to snap enabling, then no problem. As I created this line, there is no difficulty. Snap, snap. But here the case is different. Start the line drawing process. Okay, first point, starts from the midpoint of this line. Okay, no problem, it can be indicated. Midpoint can snap cursor. With a click, I indicate it. Or say that you know the coordinates of the starting point, or you know where it is. Either use snap facility or by typing XY values, define the point that it is the starting point. And now system started the simulation. But unfortunately, the ending point is not a midpoint, not a terminal point. I know that the line is to be created just at such a place. Its terminal point must be precisely located along this boundary. but the ending point is not at a characteristic location. What can we do? In such a case, move the cursor furtherly. Okay? You know, I'm going to use trimming technique. Have such a further extension. Well, I don't know the length, but say after moving the cursor furtherly away from the boundary, okay, let me toggle off track facility. I don't want to see track lines. Okay. For having such a further extension into the first box, it is now being highlighted which number is to be written. Length, as the length of this line, it has a further extension, is in this order, 300 and for instance 20. I see from the box the order of magnitude of such a line which is at this stage to be created with such a further extension. And then clicked on tab key. In this case, I know it is inclination angle. Okay. So, well, it is the case. Right inclination angle, for instance, inclination angle is equal to 12 degrees. And then press enter. Press escape button. And then the rest. Well, the line which is required as the projection of a surface is extending from here to this point, which is along the boundary of this region. But now at present the line has been freely extended, arbitrarily extended. So, well, what is the thing to do after this stage? Start trimming process. Yeah, use trim technique. Clicked on this button, start the trimming process. Press enter key. Yes, it is a trick to be able to take a right to trim the unnecessary parts. Don't forget, clicked on trim button, start the process, and clicked on enter key. And then the rest, indicate the unnecessary part, this further extension. Yes, partially raise it and then press escape button. That is it. You see now the terminal point of the line is along the boundary of this region precisely. Yes. Okay, for creating piece of straight lines, those may be the case to deal. Okay, I tried to answer the question how a piece of straight line, of course under title Classical Method, is created. I considered different cases. We know length of the line angle. We know delta x, delta y. We know that line is to extend in the horizontal vertical directions. The line is to extend from characteristic point of an already created one to the characteristic point of the other. So use snap facility. And then last exercise I said that, well, the terminal point of the line is not at a characteristic location. How it can be ended precisely along a certain boundary. I said use trim technique. Have further extension and then trim the unnecessary part. Okay. And then, well, a more difficult case, I'm going to focus your attention under the same title. Sorry, not more difficult. In other case, but in the case there will be a tangent line. Well, first let me save this file without forgetting in the memory to record that I talked about such things. Okay, say that straight lines, write the surname first. You know my kind request, ID number, and then write a meaningful text here. It is the classwork or demo about straight lines. So straight lines in general, let me write this word. Okay. I selected classical method, so write this word to remind myself that I demonstrated things under classical method title, classic. Yes, and today is the 2nd of April 2. It is like a barcode. Well, you see full of info. Who is the creator? What is the subject, and at which time, on which day it has been studied. Save the file. Okay, and then, well, clean this working area, deleting those things, and then say a different case. Well, in this case, there will be, say, two circles, and the line, yes, the issue is to deal is a piece of straight line to have. Well, I'm going to use this scenario. Say that the case is something like the one, okay, which is similar to this exercise, this case. Yes, you see there is a circle here, another circle there, and what we have, a piece of straight line. The characteristic of the straight line is tangency. It is tangent to both. Why we have such a tangent line? In this example, you see there is a flat tangent surface. It is with respect to the cylindrical entities. So assume that it is the case and need to study at that part of the drawing issue. Well, first stage, preceding stage, say that you created the circles. How? Demonstrate. Well, it is recommended in classical method, first create the axis of symmetries and then create the circle. Okay, shall I select the axis layer for creating the axis, symmetry axis? No, no need, because, well, not a matter the active page or selected page is. The output of the process, it is started using this facility, symmetry axis creation facility, is automatically routed to the content of axis layer. Okay, to axis layer. Because for this facility, these are symmetry axis creation facility options. There is a system layer. You know, I already talked about such a relationship. If for a facility there is a system layer, then no need to select the layer. Just apply the process. Okay, select center line cross option. And then, well, system asking me on the center point. I said that create horizontal vertical symmetry axis. Of what? Of a circle. Okay, the necessary circle. Well, the abscissa value in this example, say that if you know input xy values, or if you do not know but you know that approximately the circle to have is at such a location, we move the cursor to the region. Well, the circle is expected to be over there, and then make a click. And then move the cursor outwardly. And now system asking the diameter. You see in the first box saying that, okay, the symmetry axis, okay, are to be created, but for which circle? Write it as diameter. Okay, say that the diameter of the circle is 100. Write it and then press enter. That is it. Now the axis of symmetry is perfect. And sure, these are created, have been created in axis layer. Line type is as we configured, as it is configured for axis layer, say thin line and long dash, short dash. Okay. And then see this case. Between the center of the circle and the center of the other circle, yes, there is a distance 120 minus 50. 120 is the distance from this center to that center. 50 is the distance from this center to that center. So 120 minus 50 is the distance in the x direction from this center to that center. It is 70 millimeters. Okay. I marked the first center point arbitrarily, but the second center point cannot be marked. Okay. Turn back to here. Well, one coordinate 70, the other coordinate of the second center point, the center point of the second circle is 70 and 130. Say that it is the example. Okay, relative to this point, how can mark the center of the second? Or well, okay, answer the question using transfer lines. You know, my favorite method to mark the points is transfer lines. If relative to a certain point need to mark another one, then use transfer lines. Okay, I dropped the list of the options. Shall I select transfer line layer? No, no need. You see the selected page still the third visible outline layer. But I am sure if I use this tool, the created transfer lines will be created in transfer line layer. Select parallel with full distance option. Start the measuring stage and also this stage to create parallel, horizontal, vertical lines. These are the transfer lines to mark the necessary point. Okay, with respect to the symmetry axis, vertical symmetry axis or the center point of the first circle, yes, I know the coordinate of the other center point. So indicate this vertical line as the reference and then into the box write the coordinate value. The distance between the center of the first circle to the center of the other is, in my example, 70. Press enter. And then move the cursor to the right. Why? Because the second point is at the right hand side. And then click the mouse. Yes, I created this transfer line. I am sure that well, the center of the second circle is along this transfer line, where, you know, 130 millimeters away in the vertical direction. So, okay, indicate this horizontal symmetry axis as the reference right now, and then into the box write 130. Press enter, and then the second point is along this transfer line but at a higher level. So move the cursor in the up direction and click the mouse. Press escape button. That is it. This intersection is the center of the second circle. And after marking the center point relative to this one, well, use the axis creation facility. Click on center cross button, and then now system asking where is the center. Do not arbitrarily make a click. I don't know the coordinates, but say I know that this is the center point. Snap this intersection. And then diameter. Well, the circle, diameter of the circle, AutoCAD asking, okay, then axis ready to be created, but the axes are for which circle? Write the diameter of the circle. Say that diameter of the circle is 30. Press enter. Okay. And then after creating the symmetry axis, then no need to keep the visibility of transfer lines. Turn the lamp off this layer. And then see the symmetry axis. Then create the circles. Well, I'm going to create the circles in visible layer 3. Drop the list of the options and then, well, select center diameter option. And then started the process. System asking me on the center point. I know that this intersection is the center. Click. And then the diameter. I know that diameter is 100. Write it into the box and press enter. That is it. You see, I created the circle, well, having further extensions. Actually, AutoCAD, in creating the symmetry axis, asked me on the diameter. So, using that diameter value, created the symmetry axis in the correct order. You know the agreement. Symmetry axis are to be created in the length for having further extensions. It is a must. So AutoCAD at the background satisfied that format requirement and created the symmetry axis in the correct order. Okay, restart the circle creation process, selecting diameter option from the list. Indicate the center of this intersection as the center of the circle, and diameter I know 30. Okay. Well, this is the preceding stage, and what I am talking about it, not only circles, how these are to be created in classical method, but mainly my purpose is to talk about this case. Say that a straight line is needed. It must be tangent to both of them. In classical method, how it is created? Well, it is a little bit tricky. First, start the line drawing process. And then, after starting the line drawing process, this is important, there is a must. You must change the snap enabling configuration. Bring the cursor onto this listing arrow, drop the list, and deselect, deselect, deselect. Only enable the software for indicating tangent points, or for enabling the tangent points to snap cursor. If you say that, yeah, well, it is too long to make declick, declick, click, 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 deselect, deselect, then okay, I recommend select the last option from this list. It is snap setting dialog, object snap setting dialog. Click on clear all button to disable software from snapping. Make the enabling only for tangent points. Make a click into this box and then say OK. After making such a snap changing, configuration changing, enabling changing, and then the rest is quite easy. Move the cursor to the vicinity of the circle. The line which is required is to be tangent to the circle. Where? At this side? Yes. Okay, then move the cursor to the vicinity of the circle at the correct side, at the correct quadrant. The line is to be tangent at the 1, 2, 3, 4, fourth quadrant of the circle. So move the cursor, you see in the vicinity of the circle I am seeing a tangency symbol, green colored tangency symbol. It means cursor is close enough, so if I make a click, then tangent point can snap my cursor. Click. Yes, now AutoCAD understood that the line is tangent. And then move the cursor to the vicinity of the other circle. Well, shall you create the tangent line like this? Tangent point is expected at the fourth quadrant. If the answer is yes, move the cursor to the vicinity of the second circle, at it is fourth quadrant. And then after seeing the tangency symbol, make a click. Press escape button, that is it. Yes, this is the procedure to create a tangent line with respect to two more entities, two circles in this example. Okay. Well, one more time demonstrate how a tangent line is created. I'm going to make the demonstration on visible one page. I selected this layer and start the line drawing process. Don't forget, yes, change the snap configuration after starting the process, not before. Order is important. First start the line drawing process and then change the snap setting. Bring the cursor onto this listing arrow to the snap, object snap settings, and in this dialog box click on clear all button. This is for disabling software from snapping, and enable it only for tangent points. How? With a click into this enabling box and then say OK, and then the rest. Well, the tangent point is to be at the second quadrant of this circle, I know. So move the cursor to the vicinity at the second quadrant. After seeing the tangent symbol, click. And then, well, I know that the tangent point, second tangent point is to be at the fourth quadrant of this circle. So move the cursor to the vicinity of this other circle at its fourth quadrant and see the tangent symbol and then click the mouse. Press escape button, that is it. Yes, this is the thing to do in classical method. Well, this case is not so difficult to deal. The only trick is that start line drawing process and snap configuration. Enable the software for tangent points only. How about the other case? It is the most difficult case to deal. For instance, it is the case there is a line, or this one maybe, well, I'm going to use this example. There is a circle and there is a line. It is tangent to the circle, but it has only one tangent point. If the tangent line which is to be created has only one tangent point, then it may be the most difficult case to deal. Because to be able to create the line satisfactorily, well, there are 4 tricky things to know to deal. Start and see how. Say that similarly, well, a line is needed. It must be tangent to this circle, but it has only one tangent point. Okay. Start the line drawing process. And then the first trick. Teach to the software that the line is tangent. How? Changing the snap configuration. You know this. Click on to this listing arrow and then select snap setting option. And then clear all and enable the software for tangent points only. And then say OK. And then bring the cursor to the vicinity of the available circle to which the line must be tangent at this quadrant. So indicate the circle at that quadrant after seeing tangency symbol. Okay, and then yes, the line simulation has started, but you see case is strange. There is no arc simulation. There is no boxes, okay, to write the length, etc. Well, the second trick, it is important to say that you're going to write the length value, input the angle, etc. relative to tangent point. It is a must be able to have at symbol. You know how. Alternate group key, clicked on Q key simultaneously. Well, you see now along the train there is a new compartment. It keeps at symbol. It is the second trick. And then into the box, it is now being highlighted. Write the length of the line. If you know the length of the line, write it. If not, then for having a further extension, thereafter to trim the further extension, write a bigger number into the box, making a guess. But say that in this example, the length of the line I know, say, is 70. Write 70. And then, well, into the other box, write the inclination angle. But you see in the box, there is a number negative and there is no degree symbol. So, well, it is the indicator, and also there is no arc simulation in the screen. It is now to distinguish that AutoCAD not ready to gather the number which you're going to write it into the last box as the inclination angle yet. What can we do? How we can teach to the software that the first number is the length and the second number is the inclination angle? Well, in such a case, not by clicking on tab key. If there were arc simulation, then just simply clicking on tab key, we will teach to the software that the firstly written number is the length, second number is the inclination angle. But here it is not the case. In this case, to teach to the software that the first number is the length and then the next number is the angle, clicked on another key on which we have less than, greater than symbols. Okay, it is the angle key. Clicked on that key of the keyboard, less than, greater than symbols we have on it. Yes, and now AutoCAD understood that it is the length and the other number is the angle. You see within the last box we have angle symbol and degree symbol. It is the third trick. And the last trick. Well, into this box, write the angle as measured in which direction. Imagine that there is a horizontal line. It passes through the tangent point, through the point at which the line is to be created is tangent to the circle. Imagine that horizontal line, and relative to that horizontal line, calculate the inclination angle of the line, which is the line to be created, in the counterclockwise direction. Say that relative to the horizontal reference line, it passes through the tangent point of that line. Okay? The inclination angle of the line in the counterclockwise direction is equal to 240 degrees. This is important. Okay? And then press enter. Press escape button. That is the line. Managed to create it. Well, I mean, do not input the angle, any say inclination angle in any direction. Say that, imagine as if you have such a reference line, horizontally oriented, and it is passing to the tangent point, and relative to this horizontal line, calculate the inclination angle of the line as measured in the counterclockwise direction. Now in this example, 60 is the available angle, inclination angle, but it is not with respect to that horizontal line. While with respect to that horizontal line, inclination of the inclined line is 60 degrees as opposite angle, but in the counterclockwise direction, the inclination angle is 180 plus 60, 240 degrees. So here, in creating this tangent line, as it is inclination angle, I wrote the angle 180 plus 60 degrees. So yes, it may be the case. A line, it must be tangent to a circle, but it has only one tangent point. Then there are 4 tricks. What? Change the snap setting after starting the line creation process, and then indicate the circle. The second trick, don't forget to have add symbol. Third trick, well, after writing the length value into the box, to teach to the software that the other box is to write the inclination angle, clicked on angle key of keyboard. And the last trick, okay, write the inclination angle as measured in the counterclockwise direction relative to a horizontal line which passes through the tangent point of the line. Yes, dear students, well, I talked about different cases, well, to have a piece of line in the end, applying for all the classical method. Well, next video record will be on a complete projection, which consists of piece of straight lines. See you then. Well, I am ending this video record. Well, stay healthy. Bye bye.